All right, let's continue on just for a few more minutes. We'll keep this second video short. So we did our exponential problems, and especially this last grouping here, kind of talking about how you manipulate the fraction and then also the number itself. Just some things, little tricks that help make this problem a little bit easier to get through. Now, switch to our power functions. The power function is a little bit different idea in terms of solving. You can, again, do a reasoning. In some cases, you can reason it out. Others, you may have to actually do a little bit of exponent work to get your answer, and that would probably take you to a calculator. The first thing I could do is ask myself just the question, what to the sixth is 64? And you might be able just to answer that. Some of you guys may not, but if you think it through a little bit, that's actually 2. So 2 to the 6th is 64. An alternative to that is saying, like, some of you guys go, well, I don't know if I can get that in my head. Maybe I'm not that good yet with the bigger exponents. You might just decide to do a little bit of solving. The way you do it as a solving problem is you have to figure out how you'd eliminate the exponent. And the way you eliminate an exponent is you raise it to its reciprocal. So if I have a 6 and I raise it to the 1/6, now think of the rule of exponent that says a power to a power is multiplication. So 6 times 1/6 is 1. This, you would probably still end up going to your calculator to do the actual work of it, but you'd still get your x equals 2 going on. So the same result would happen there. It's a way to eliminate an exponent where you maybe say, no, I don't know if I can reason that out or not. So raise it to its reciprocal and then go to your calculator. 0.5 as an exponent would actually be 1/2. So I think here you probably are not going what to the 1/2 is 15, because we haven't talked about exponents as roots yet. It's coming down the road a little bit. So I think what I would do here is just think of it as, hey, how do I get rid of the exponent of 0.5? I multiply it by its reciprocal, and the reciprocal of 0.5 or a half is 2. So power to power, that becomes a 1. And then here, just again, go to your calculator or do it in your head if you can, 225. This one, I think it kind of could go either way. I think you probably could answer this. I mean, we should be, we know our squareds pretty well. We should know our thirds pretty well. When you take a question mark here, what would you raise to the third to get 27? I think most of you guys could probably say 3. You do have the option of the or, right? So it's like, well, no, I'm not there on my exponents that are bigger than 2. Then what's its reciprocal exponent? So 3 and 1/3, 3 times a third is 1, so raise it to its reciprocal. That would give you just plain x. And then this, again, you probably have to go to your calculator to finish it off if you weren't sure what that was. Still getting the x equals 3 answer. Okay, that finishes up the exponential compared to power functions and how we solve. Quite a bit of variety going on there. Some of it, I think, pretty simple. Some of it's logic. Some of it's actually trying to manipulate the exponents themselves. But I think it's all pretty doable. Let's go to graphing. So the last thing we'll do is hit the power function idea. And the reason we're going to bring these in is like another family of functions is connected up to transformations. So what's going to happen now as we kind of run through different days, different lessons moving forward is we're going to go back to the idea of, all right, here's a graph, and then transform it, talk about shifting, because we can apply those to any kind of graph, even if we're not studying the graph as part of the chapter, as a bigger part of the chapter. But in terms of me just getting the graph going, what I would do is now use the idea of exponent and plug in. So plug these numbers in. So -2 to the third, which is -8. You'll see my points kind of popping up as we go here. -1 to the third, -1. 0 to the third is 0. 1 to the third is 1. And 2 to the third is 8. And then it creates this image. Connect those dots up, and there's my graph. What you guys will be asked to do is maybe a little bit of graphing. And since it's not a graph we've studied, like here's the design. Generating points in a table is pretty easy to do. This is also generally a pretty good set of coordinates to pick, -2 to 2. Doesn't take that long to do that. We can raise numbers to exponents. And then the last thing we'll do is talk about shifting that graph. So we've done the shifting ideas before, and it's pretty simple for going from black to red. It's a counting idea, and I would count from a corresponding coordinate. So if I start at this 0, 0 coordinate and I count, what are my movements, right? So we're going right 3 and down 5. So right 3 down 5 would look like right 3 down 5. Remember, insert those into the equation, so we're going to go ahead and plug those in. Right 3 down 5, and there's my final version. Right? If it wasn't up, so let's say it was a left, then think of it as being a negative number. So when you plug it in, minus and minus is plus. Remember that idea, how that sign changes in parentheses? But again, I think pretty easy to do. Okay, that's going to be the end of our 4.2 notes.